Hey there, it's Karen with Mini Math Lessons. So today we're going to be looking at dilations. And so here I'm on Classpad.net. I'm going to get the URL of the free activity included in the description below. And this will bring up the activity on dilations. Here is the activity, and there's a couple different components of the activity. So this first one is basically describing the dilation, and it's saying this blue is the original, and it has been dilated using this point of dilation here, D1, this scale factor, and we end up with the resulting image, the green one. And you'll notice that a couple things are measured, so two corresponding angles and then two corresponding sides. So this 1.9 actually has to do with that one right there. We'll move it a little closer. So in the first part of this activity, they're just going to be using this slider to explore some things. So right now the dilation scale factor, dilating the blue into the green, is 2.6. And if you notice, the green one is much larger. All right, so does that have to do with the scale factor? So they're going to be able to play around with the sliders. And so let's see what happens if we make it be a negative number. So negative 1.5, it's a little bit bigger. Our scale factor is 1.5. And negative, what did the negative seem to do? It seemed to flip it over on its side, so maybe make it the inverse, the reflection almost of it. So lots of things they're going to discover just by moving the sliders. So let's see what happens if I do a number smaller than 1, and now my green is smaller. What if I get larger? So the scale factor, if it's larger than 1, seems to make it bigger, and negative seems to flip it. Things like that they're going to discover. They're also going to be able to, move the point of dilation. What happens when the point of dilation is further away from the pre-image? What happens when the point of dilation is inside the pre-image? So then our dilated figure is around the original figure. So lots of things they're going to explore just by moving things. So they're going to be moving, they're going to be, they can even move the angles. And what do they notice? Well, the shapes change exactly the same. One's bigger, one's smaller in this particular case. So lots of things they're going to be exploring just by moving sliders, the dilation, the points. And there's questions over here that they're eventually, by the end of this little exploration, they're going to have an understanding of what a dilation does. So we want them to understand that it seems to keep the angles the same measure between the two images. The point of dilation, the scale factor, determines how large the image is of the pre-image. So if it's larger than 1, I'm going to get a shape larger, and if it's smaller than 1, I'm going to get a smaller one. If it's negative, it's going to be flipped, those types of things. So lots of things are going to explore and eventually come up with an understanding of what a dilation does and why it's also considered a non-rigid transformation. Hopefully they've already explored the rigid transformations before this. So non-rigid, one main thing is these are not keeping the same size, and that's part of being rigid, is that it's the same size, same shape. So that's where we're going with this first part. So then as we move down, we're going to get a little bit more precise. And now we're really going to focus on that proportional relationship between a pre-image and its dilated image. And so you'll see I have the same thing here. I have a dilation. Here's the scale factor. Here's the measures of corresponding sides. And we're assuming after this exploration that they've already understood that dilated figures corresponding angles are always congruent. So we're not going to be focusing on that. We're now going to look at the relationship between corresponding sides. And instead of a slider, the dilation here is a given number. And they're going to explore things, again, moving the dilation point, moving the angles, and they're going to actually do some calculations. So one of the things that that's asked is, all right, what's the ratio between corresponding sides? How does that connect to this scale factor? And so they can just go up here to the calculate sticky, and we're going to do pre-image over image. So it's 2.6 in this particular case over, what was it, 1.3. And so, oops, I did that backwards. 1.3 over 2.6. And the ID, so I said that wrong. It's image over pre-image. What's the ratio? And so, they're going to compare all the different size, corresponding size, and they're going to find out that they have the same ratio and that it matches their scale factor, right? And so we're going to do that, and then I'm going to ask them to change things, and let's get a new calculate sticky up here. We'll ask them to, change the dilation. And so now instead of a slider to change the dilation, you just type in a new number. So let's type in 1.2. Right? So what happens, hopefully from the experiment up here, they know that it's going to get bigger. So the green one, which is the image, is going to be larger, slightly larger than the original. They can move the dilation if they want, so that they can maybe move the point so they can see the sides a little bit better. And then they're going to compare the corresponding side ratios again and come to the same conclusion. So the whole point of this activity is to understand that the scale factor gives you the ratio between corresponding sides. That's where we're going with this. So then the last piece of this activity is still working with the corresponding sides, but also what's the relationship between these vertices and this point of dilation? Where is there a relationship there as well? So again, we're assuming after these first two explorations, they have come to the conclusion that angles remain congruent in both images, that sides are related proportionally. All the sides have they have the same ratio that is equivalent to the scale factor. And now we're going to look at some other things. So they're going to play around with this. They're going to be able to change the dilation here. So like ideas of how could you find this point of dilation if you didn't actually have it, but you had the image and the pre-image. And so they're going to basically explore. We've connected each corresponding vertex to each other, and what happens is they all seem to go through this point of dilation. Well, that's a really cool thing. And does that happen if I change? Does that stay consistent if I change the dilation? So let's change it to be something smaller. And it still does change. Let's change it to be something negative, which we already know flips things around. Let's make it just be. Does it still same? And so you'll notice that whether it is a dilation and also a I guess that'd be a reflection. Is it keeping the corresponding vertices connected and going through this point of dilation? And the answer is yes. So that's what we're trying to get them to figure out here. And let me change this back to, no, it's fine. And then what they're then going to do is, okay, so we kind of have this interesting thing that happens. So if I only had the two images, I could find the point of dilation by connecting corresponding points with a line, right? And then is there a connection between the distances? And so you know what, let's change this back to something we can actually see. I think, was it 2? 2. So now if you notice, we've measured the distance from the point of dilation to each of the corresponding vertices, right? So the distance here, dB, I've measured is 3.2, and then the distance d all the way to the dilated image of B, so B prime, is this. And then they're going to, again, use their calculator to compare, is there a relationship here? And they're going to find out, again, that this is connected to the ratio. So by the end of all this, they're just going to really understand how important the scale factor is, how they can find a point of dilation if they just have the two images, and what's the relationship between corresponding sides to the scale factor, and also what's the relationship of corresponding angles. So that's the whole point of this this series of investigations about dilation. So hopefully by the end they really have an understanding of what dilations do, how sides are related, how that scale factor really impacts everything, those types of things.